Hello, students. Today we are going to be doing elimination part 1. So this is another method other than graphing and substitution. So this is the third method in our selection of methods to solve a system of equations. So remember, a system of equations is when we have two equations or more. We'll be working with just two, and we're trying to figure out what the x and the y value is. So here's an example, x. So that's a system, and we want to find out at what x and y value combination will these both be true at, okay? Or like on a graph, where will they intersect? So before we get into solving it, let's just talk about some things that you can do with a system of equations. Um, So one thing that you can do is you can add them, right? You can take two equations and add them. So for like an equation bar, kind of like the old way that you would add numbers. I'm just going to add like here. Now, in order to add them, we do have to have the x's, the y's, even the equal signs and the constants all lined up perfectly. So they have to, each equation we say has to be in the same form. So right now these, I already made this one, they're all in the same form in order for us to be able to add them. So adding this, there's an invisible 1 in front of that x. So this will then be 3x. 4 plus negative 3 is going to be positive 1. So plus 1y equals 16 plus negative 23. That ends up equaling negative 7. Okay, so that's something that we can do. We can take two equations and add them together. Another thing we can do with a system of equations is we can subtract them, right? So very similar to adding. It's a little trickier because you have to just remember you're subtracting every time. So 1 minus 2, that's negative 1x. 4 minus a negative 3. All right, so maybe right off to the side. 4 minus negative 3. And remember, when you're subtracting a negative, that's the same as adding its positive, right? So that's the same as 4 plus 3. So that ends up being positive 7. Y equals 16 minus negative 23. So again, 16 minus negative 23. So again, that's a minus a negative. That's like adding. So that's going to be 39 because you're just adding those together, right? I guess 16 plus 23. Okay. All right. So you can add equations. You can subtract them. Now, how can we utilize that to help us solve an equation? Well, you might notice that I called this part 1, right? This is part 1 of this method. So we're gonna first start off with equations where when we add them or subtract them, something happens where we then can solve from there. So here's an example of a system of equations, and I'm going to take them and I'm going to decide if I want to add them or subtract them. And the goal here is if I do one of those things, one of the variables will cancel or will eliminate, hence the name of our method here, elimination. So if I look carefully, these ones I'm not as interested in because they're different coefficients on the x terms. But on the y terms, they both have a coefficient of 2, or at least 2 and negative 2. So when they're opposite like this, that's when we want to add, because when you add opposites, they create 0. So what you would end up getting here would be 8x, right? Now here, negative 2 plus 2 is 0. So you could write it in technically as plus 0y equals 12 plus 4 is 16. Now we don't typically write that 0y because we know that when we have 0y, that's 0 times anything is nothing, and then nothing plus 8x, we don't have to do. So oftentimes I'll just put a slash through those. Maybe I'll put an X. Should really show that we're canceling it out. So truly this is actually, let me cancel it here as well because this is 0. So really I only have 8x equals 16, which is a pretty simple equation to solve. If we just divide by 8, we can solve for x. And then the 8's cancel, they become 1, and we're left with x equals 2. All right, now remember, we're not done yet. That's just half of my answer. So I could start, if I'm going to start writing my answer, I know I have the x value is 2. I still need to know what the y value is. So if you recall in the method of substitution, once you find out x or y, you can then plug it back into one of the original equations to solve for the other variable. And we're actually going to do that with this method as well. So 2 here could go, here, let me get the highlighter. So 2 is the same thing as x. So let's find I can either put in this x or in for this x. Either way would work. Just to choose one, I will go with this top one. How about? So then that would look like this, 3. And now I'm plugging in the 2 in place of that x minus 2y equals 12. All right, now notice that we have an equation where the only variable is y. So we can solve for y. 3 times 2 is 6. And then the next step would be to subtract 6. And then we would have, that'd be negative 2y still, equals, that makes positive 6. And then we would divide by negative 2. And that would eliminate there. And y equals, that makes negative 3. All right, and so then that is the y coordinate to negative 3. Okay, here's another example to take a look at. In this system, notice that we have the exact same coefficients on the y value. So to eliminate them, it would make more sense to subtract, right? So whenever they have the same sign, that's when you can subtract to cancel them out. And this is a negative 1 in front of the x. So 5 minus negative 1, that's actually the same as 5 plus 1, so that's 6x. So just be careful with that. 6 minus 6 does make 0, so I can eliminate that term, right? So we will not have a y to worry about. Bring down this equal sign, and then 50 minus 26 is 24. All right, now this is just a little more spaced out, but yeah, it's 6x equals 24. So then solving for x, I would divide both sides by 6. And we would get x equals, 24 divided by 6 is 4. Okay. Same thing as before. Well, yeah, so I know that's my first half of my answer, 4. Now to get the y coordinate, let's plug 4 back in to one of the x's of the original. So I could plug it in this top one or this bottom one. Wouldn't really matter which one. I'll choose the bottom one this time. So that's negative 1, but that, well, yeah. So I could just write it as negative, and then it's x. So the opposite of x, well, my x value is 4, so the opposite of that is negative 4 plus 6y equals 26. All right, so this one's kind of nice. Just have to do 2 steps here. So next step would be to get rid of this negative 4, so we're going to add it to both sides. So those make 0, so they cancel out. So then you still have 6y equals, that makes 30. and dividing by 6 on both sides. We get y equals 5. Okay, right, 30 divided by 6. And that is the y coordinate of our solution. All right, here's a third example to take a look at. Now, take a look at this one. This one's, you have to look a little more carefully. The terms are not, they look like they're all lined up perfectly, but notice that the equal signs are not lined up. So this is actually, we can't start adding or subtracting this equation just yet. So we have to do a little rearranging. So I see that if I want to get this equal sign to, so here, I'm going to try to match the top one into the same form as this bottom one, where it's got x, then the y equals the constant. If you look, if you remember, this is standard form. Remember, ax plus by equals c. So it's in that form. So I'm going to try to get this top one in that same form. So the issue is this y term is on the wrong side. So if I subtract 7y from both sides, the y term will cancel on the right. And now, let's write it over here. That'll be 5x minus 7y equals 14. All right, and I'm just going to rewrite this one underneath here. Negative 4x minus 7y equals negative 49. Now, if you look, these are the exact same sign, okay? So if you remember, to cancel out the same sign, we're going to subtract. Now, it's a little trickier when they're both negative, but that's the same thing. So we're going to subtract 5 minus negative 4. That's the same as adding a positive 4, so that's 9x. Now, negative 7 minus negative 7 does equal 0, all right? Negative 7 minus negative 7, because that's another way of saying negative 7 plus 7, which we know is 0. So that does cancel or eliminate. And then we're left with equals 14 minus a negative 49. That's the same thing as 14 plus 49 is 63. Okay, so then when we divide by 9 here, those 9's cancel over here, and then x equals 7. All right, so that's my first coordinate. Now all of these I've been finding the x value first. It is very possible that you find the y value first. I just the way I've been setting these up is all. Okay, so now let's take this 7 and plug it in for one of the x's of the original. How about the top one? So 5 times 7 is equal to 7y plus 14. So that's 35 equals 7y plus 14. Solving for y, we would subtract 14 from both sides. That cancels on the right side there. So what is that? 21 equals 7y. And then dividing by 7. We get 3 is equal to y. All right, so then that can go in our ordered pair here. All right. Okay, so your assignment is IXL U.10, and I'm only looking for a score up to 70 here. The questions past 70 are going to be, and we're going to go over those types of questions in our part 2 notes for elimination. All right, good luck, and come back for part 2 once you've gotten to 70.